Our goal in this video is to get a rough sense of size and scale of things in our solar system. We're going to look at the main objects and see how big they are and how far away they are. To make this simple, we're going to round our numbers a lot. We're also going to pretend that planets and orbits are perfectly round. To keep things simple, we're just going to use one type of measurement, radius. In case you haven't done maths for a while, radius is the measure from the middle of a circle to its outside. Let's quickly cover what the solar system is. Assuming you're on Earth, which is likely, you've got some silicates and iron and nickel and stuff under your feet, maybe a bit of water if you're out at sea. Collectively, that's Earth, and Earth is a planet. Earth orbits one star, the Sun, and our Sun is the only star that's anywhere close to us. The next closest star would take you about 5 million years to travel to if you traveled at the speed of a normal commercial jet. So in our story today, there's only one star, the Sun. Only one star, but lots of other stuff. There are planets, which is the main thing we're going to talk about today. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And then other stuff, dwarf planets. You probably know about Pluto, and quite a bit of other stuff beyond that, but we're not going to be talking about that. We're going to just talk about the Sun and the main planets. The units I'm going to use for this talk are kilometers. If miles are your bag, just pretend I said miles, because the amount that I'm going to be rounding things, it really doesn't matter, and it's still going to give you a good sense of the scale of our solar system. So let's start measuring, and let's start back home on Earth. When we talk about the radius of Earth, there's mountains and valleys, and there's equatorial radius compared to the radius at the poles, but we're not going to worry about that today. The radius of the Earth for now is 6,371 kilometers. In fact, I only give you such an exact number because there's one other planet that's fairly similar, and that's Venus. So after we've looked at Venus, we're going to round it down to very easy numbers. So 6,371, roughly the distance between London and Chicago. So that's the one radius that's interesting, the radius from your feet to the center of the Earth. The other radius that's interesting is the radius of our orbit from the Sun to the Earth is roughly 150 million kilometers. So if you can remember, around about 6,000 kilometers, a little bit more, is our radius, and around about 150 million is our distance to the Sun, then you're good. The radius of the Sun is almost 700,000 kilometers, so 100 times more than Earth. The first planet out from the Sun is Mercury, and Mercury is quite a hostile place. Its orbital radius is about 58 million kilometers, and since we're playing fast and loose with numbers, let's just round that down to 50 million. So 150 million was Earth's orbital radius, and Mercury's distance we'll call 50 million. Around about a third of the distance that it is out to the Earth in terms of radius of the orbit. Mercury is a really hostile place, has a day of 176 Earth days, and so you'd have daylight for 88 days in a row. Mercury's radius, that is from its outside to its middle, is about 2,500 kilometers compared to Earth's 6,471 kilometers. The next planet out is Venus, and Venus has an orbital radius of about just over 100 million kilometers, and it has a radius of about 6,000 kilometers. So very, very similar to Earth in terms of its radius. So after Venus is Earth, of course, and then the next out is Mars. Mars has a distance from the Sun around about 225 million kilometers and has a radius of around about 3,389. So let's just say 3,000 kilometers. After Mars, it's worth pausing a little bit because these planets, Mercury, Venus, Earth, and Mars, are very similar. They're all terrestrial planets, and which means they're kind of rocky, hard planets, and relatively close to the Sun. You know, the distances between from 50 million up to 225 million are similar ballparks. Once we move out beyond these planets, things change drastically, and the character of the planets we're going to look at are very different, and their sizes and their distances start to jump. While we're pausing, it's worth thinking about these distances from the planets to the Sun. So if our orbital radius is 150 million and Mars is 225 million, does that mean that we are 75 million kilometers from Mars? Well, not exactly. It depends on which side of the Sun we are. So we could be on the opposite side of the Sun, in which case, it's 375 million kilometers. Whereas if we're on the same side of the Sun, it's down to 75 million. So you have to take that into consideration when you're thinking about the distance between the planets. If you have any interest in SpaceX, this is obviously a big consideration for them. They need to plan flights to Mars when it's feasible, when Mars is close enough to get to. The next planet out from the Sun is Jupiter, and it's a huge jump further. Jupiter is about 750 million kilometers from the Sun and has a mean radius of around about 69,000. So if we think about the radius, Earth just over 6,000 something, Jupiter over 60,000, the Sun over 600,000, we're going up in steps of 10 in terms of the size, in steps of magnitude. Jupiter is also a whole different category. Not only is it absolutely giant, the largest planet in our solar system, but its character is very different. Jupiter and the next one out, Saturn, are what they call gaseous giants, so you can imagine them like huge atmospheres, rather than rocky planets like we had with the first four. The next planet out after Jupiter is Saturn. Saturn's absolutely wonderful. If you've never looked at Saturn through a good telescope, it's something worth doing. And it's a whole jump again in distance. If you take the word billion to mean 1,000 million, then it's 1.5 billion kilometers from the Sun. And it's, again, relatively big, just under 60,000 kilometers in radius. So on the same scale as Jupiter compared to Earth and the other planets. After Saturn, the next planet out is Uranus, and it is very far, 3 billion kilometers. 3 billion kilometers, and has a radius of about 25,000 kilometers, so about half the size, if we're taking very rough scales, of the two big gaseous giants of Jupiter and Saturn. And then the final planet out is Neptune. It's about 4.5 billion kilometers out and also has a radius of about 25,000. It's incredibly far away. If you were to travel at the speed you travel in a commercial airliner, it would take you over 500 years to get there, whereas it would take you about 22 years to get to the Sun. It might just be a spreadsheet of numbers, but it really helped me when I was first understanding astronomy, getting into astronomy, to get some perspective. If you look at Mars and Venus, they're really our near neighbors. We're talking about hundreds of millions of kilometers away, but in comparison to Neptune, it's nothing. It's just around the corner. And you can also imagine that if you're on Neptune or Uranus, the Sun is significantly dimmer. It's going to take a matter of hours for the light from the Sun to reach there, whereas the sunlight takes just about 8 minutes to reach us. So the further ends of the solar system are extremely far away, and also explain why not much exploration has been done of Uranus and Neptune, whereas it's quite an amazing achievement that we've actually done quite a bit of exploration around Jupiter and Saturn and their many moons. And it's a topic that I find very interesting, and I might make some more videos in the future about various things. There's all sorts of aspects of this that I find really interesting. Hopefully you found some of it interesting, and if you did, I'd love it if you subscribe. And thank you for watching my video.